In the name of God, in the name of without doubt is capable and voice, welcome to our own channel. I hope all of you be healthy and fine. Today we are going to start the sixth episode of Learning SAP program. In this episode, we are going to design the Pratt truss. In the previous episode, we have been started the design of the truss, and we talked about the truss, that where we use truss, what is the usage of the truss. In this episode, we are going to design another type of the truss that we called this Pratt truss. If you see here, we have the in here every panel length is 6 meter, okay, and in here we have also 1 meter height, and also in here is it is actually a triangle, and also this portion top chord is actually 2 meter. It means that our crown or peak height is actually 2 meter. Then in here we have the 50 kilogram load in the each panel point. From the two outside panel point we have 50 kilogram load, and inside of the panel points we have 100 kilogram loads. Our type of the section, we should design this section in a double angle section, and the minimum yield strain is 3200 kilogram per centimeter square. So let's start it. First of all, we have to go for new file, or you can also go by this option or Control plus N. In here we can you can plot this 2D truss also by grade and also by 3D truss. If you want to go by grade, it's a very easy, as I told you that in here you have an x direction, that how many points we have in x direction. First of all, it's okay that you first draw for the first portion, and then you can get mirror for the other portion also. Means that if you want to plot by a grade, so you first of all you can draw from this point up to midpoint, okay, and then draw all the panel points, all the panel lengths, all the top chord, bottom chord, and also the inner portion, inner section, and then just by mirror you can draw automatically this portion also, because this truss is symmetrical truss. Because if you see, we have the three panel length in this side and three panel length in this side, that each panel length is actually it has equal length: 6 meter, 6 meter, 6 meter, 18, 6 meter, 6 meter, 6 meter, 18. So just I want to guide you that how you can draw by grade lines. So in x direction, first of all we have the 2 points. If you see here, one here and second one here. So in here we can select the 2 point. In y direction we don't have anything else, so we can get 1, and in a z direction we have also 3 point. How we can have 3 point? If you see, first, second and third. So in here we can give 3. Then in the x direction, how much is the grade spacing? As I told you, first of all draw for this first portion. So we have 3 panel length of 6 meter, so total becomes 18. In a y direction, we don't have anything, 1, and z direction, how much we should get? So in here, in a z direction, first of all we can get 1 meter, and then we can plot the 2 meter also. So it is your location 000 also, okay. Then in here you can come, first of all you can come here just by this draw tool, just from here up to here, okay, and then you can get from here up to here, okay. You have to select here up to here, and also we have this part here up to here. Then find your midpoint, okay, and then draw your each panel point, okay. So how we can find the 3 equal point in here? Because we have 3 equal panel length, just select here, come in a edit line, edit frame. In here, if you see number of the frame is 3, apply and okay. If you see, now it's in 3 equal portion, it should divide. So it is how that we can draw by edit line. So by template also we can draw. Template is a very easiest method. Actually both of them is easiest, but template is the shortest of the time. We have already the template of the truss, so it's a one of the benefit of a truss. Okay, a benefit of the SAP program. So in here we can select the Pratt truss because type of the Pratt truss. Now in here if you see, we don't know that what is the L1, what is the L2, what is H1, H3, N1, N2, H2. So we don't know that from which portion up to which portion is H1. Okay, if you see here, we don't know. Here is also not mentioned. But we have to know that what is the L1, what's the L2, what's the N1, what's the N2. So how we should know this? Just come in a parametric definition. Here if you see, distance from here up to here is H1, and distance from here up to peak point is H2, and H1 and H3 is actually this point. From right side is actually your H3 and from left side is H1. In our case, our H1 and H3 is same distance, 1 meter 1 meter, and our H2 is actual distance from here up to peak is 2 meter. So now we got that what's the H1, what's the H2, what's the H3. Then L1 is at the first division and L2 is the second division. In our case, L1 is L2 is equal, meaning we have to give the same value for L1 and same value for L2, and in its number of deviation, that number of deviation in this side and this side is 3 3. Now we got that what's the H1, what's the H2, what's the L1, what's the L2, what's the N1, and what's the N2. So our L1 is how much? If you see, distance from here up to here is 18 meter. So just come. Now first of all, make sure with your unit. Our unit is kilogram meter per Celsius, but also just click the shift and double click in this box. In here also it comes. Okay, so it's a meter, so 18. Our L2 is also 18. Our L2 is actually distance from here up to here. Then our H1 is 1 meter, and our H2 is also 1 meter, and our H2 is 2 meter. In 1 we have also 3, and in 2 is also 3. Okay, so now we have this first. Then if you see our type of the support, we have the 2 hinge. So in here we can also change this part has a hinge support. So how we can change? Come in a join restraint. In here this. Okay, so what is the another steps? Another step is that we should define the material. We don't have the concrete here. Okay, now we should add new material. We can get like steel. Which one you can get? 836. Okay, then modify show material. We have to change the, we are in a centimeter. Okay, so kilogram, find the kilogram centimeter. Okay, now our minimum yield stress. Okay, how much is our minimum yield strength? Is 3200 kilogram per centimeter square. See, in here I want to give another information also out of box. If you can also call the minimum yield stress and also minimum yield strength. Actually it's no different. Why? Because strength is the maximum value of the stress. What is different between strength and stress? Strength is the maximum value of the stress. So no problem. Okay, so we have 3200. Okay, and okay. Then we have the section property, frame section. We have double angle. We have to import new property. We can select double angle. Come in as sections.pro. Okay, select all of them. Okay, then again add new property, auto select list. In here we can write that double angle. So select all of them. add, and OK. Okay, now our priority is double angle. After that, we have to nothing left in here. Then we have to go for a load pattern. What we have dead load, and the second one we have also live load. So our dead load is okay. So here we can get live load and add new pattern. Okay. Then also define load combination, add new combo, dead load 1.2, add, and live load we can take 1.6, add, and OK. Then we have to define the section. So select all of them, go in assign frame section. In here come for double, apply, and OK. Then also come in assign. Then what we have to define the loads. So join loads, we have forces, dead load. In here if you see z direction is in this direction. Okay, so you have to plot the minus. So first of all we have to select this and this portion. Okay, now come in assign join load forces, we can plot minus 50. Okay, apply, and then OK. Then we can select all of them as 100, come in assign join load forces. In here select minus 100. Okay, apply, and also OK. Here we don't design for sheet because of this we don't take the live load. Now for analyze, we can, here nothing is left. Now analyze, set analyze option, XZ plane. Okay, then also analyze, run analyze, do not run according to model, run now. So we can save it somewhere in here. We can save by Obaid. Now it's a deform shape. Okay, now in here also we can design it. Come here, start design, check of structure, and here if you see no section is fill. Okay, now in here if you see we have all of them, 12.4, 12.5, 12.5, and also in here we have all of them is 12.5 and 12.4. These two is 12.4 and these three is 12.5, and at the end 2.5. So it's all the sections that we designed. And also you can see the 3D form of this. So how you can see this, just select them. Okay, then you can come in the select, and then you can come in a view, set display option. In here you can select the extrude wedge section. Okay, now you can come here. If you see 3D, so it is actually our 3D of our section. Okay, if you see it's a double angle. If you see it is the double angle. Okay, our section would be like this. So it is all about the episode 6. In the next episode we are going to talk about another type of truss that we call 3D truss. Have a nice time. Goodbye.